So today my topic is geospatial data quality and errors. So basically, in this topic, we'll be discussing about the one of the very important issue in GIS, that is uncertainty, because this particular matter of uncertainty will decide the quality of decision or quality of plan you can make by using the geospatial data. You must have learned about the basic concept now and the different data models like raster vector data models, and you know that these data models are basically are a method for the abstract representation of the reality, that is a geographical reality. Like if you want to represent the road in the computer system, especially in GIS software, generally we follow the line topology or line geometry. And then if you are looking for the playground or agriculture field, then we are going for the polygon geometry. Sometimes some features like buildings are represented as a point, but here you have to understand it is not a thumb rule that every time you will be representing road as a line only, because if you compare with the real world, you will not see anywhere point line polygons. This point line polygon concept doesn't exist in the real world. So what we are doing and why we are doing it, we are basically trying to represent this geographical feature in the computer system in the form of some mathematical or some computation purpose, like a point geometry, line geometry and polygon geometry. But in some cases, we may require the width of the road also. In that case, the line may not be considered as the appropriate geometry to represent the road. In that case, you have to represent the road as a polygon also. But when you represent the road as a polygon, then certainly some of the geospatial analysis like network analysis are not possible, because GIS says that if you are looking for the network analysis, then your geometry must be a line geometry. Then how to address it? So these are the some issues which basically you have to keep in mind when you are creating the geospatial data. So another important thing is, sometimes people says that if I am able to see a complete feature in high resolution satellite imagery very clear, like a natural photograph or natural color composite or NCC, like a playground, nicely it is visible, stadium is visible, I am also able to identify the building like a Taj Mahal. If you see in the very high resolution satellite imagery or UAV image, then you will say very clearly I can say it is a Taj Mahal. Then why I should digitize it, and why I should convert it as a vector data? Why this point line polygon is required in that case? Same, if roads are very nicely visible in the satellite imagery, then why I should create it? Why I should convert it as a vector data? That is a very important things what you should understand here. So my colleague must have cleared your doubts basically on the raster and vector data, why we use the different data geometry basically in the GIS. And another important point what we know is that if you capture the images through the satellite or through the drone or through any other mode of sensors related to geography, so these features basically what we are receiving through these images are basically giving us the footprint or the structure or structural behavior of that particular geographical features, but the characteristics, the attribute about that geographical features we cannot capture through any sensors or space-based sensors. Although based on some the relationship we call as a topological relationship, we can say that either this is a playground or this is a your agricultural land. We can decide it. But if you want to know the full characteristic of any geographical features, then you have to have the ground-based survey. So for example, suppose you are capturing an image of a building, then definitely you can say that it is a building. I am able to identify this building very easily because all the geographical features like texture, tone, its shape, size, everything is fitting of the criteria of the building. But either this building belongs to a school, this building belongs to a private building, either it is a mall, it is a shopping center, commercial buildings, or any government institutions, how this information I can capture through satellite? No, I cannot capture. If you want to attach this information with this footprint, definitely you have to go for the ground survey. In the ground survey, whatever attribute you will be collecting it, and this attribute is also known as a non-spatial data, and then you will be linking with this building footprint, and then it will become a full GIS database. So further you can make a plan, you can make a query, you can do the modeling and so on. So here when we do this exercise of capturing of the footprint through the sensors, ground data collections, linking with the linking of non-spatial or attribute data with the geographical features, during this time there is a chance of some errors. There are chance of some errors. So here we have to understand different GIS data models. For the real world phenomena, we know about the raster and vector data model, TIN model, DAM, and so on. And then the errors are very, very important, and these errors basically arising in the different stages of GIS, either for during the capturing, during the data collections, and in fact sometimes errors occurs during the entering of the data into the system, and some error occur during the processing of the data, and sometimes some computation errors also are there. So today we will understand what are the possible source of these errors, why we should study these errors. The spatial database has a problem because the real world phenomena are not always discrete but also fuzzy in nature. If you see that in GIS we are simply drawing the boundaries, but in real world these boundaries are not like simple lines, rather it is a fuzzy in nature. So you cannot pinpoint, or you cannot say this boundary ends here itself. So there will be some fuzziness, and it depends the size of the pixels or size of the raster image what we are capturing. It's decide how much accuracy is there in this data. So here there are cause of errors in the spatial data, like we can say like a measurement errors, and these measurements are errors are basically resulting the accuracy of the data. Example is like altitude measurements, soil sample, and usually related to the instruments. So when we are measuring the someday information about the geographical features, either through the ground-based sensor or space-based sensors, or maybe some manual method also, so these basically are considered as a measurement errors. So sometimes if instruments itself is having some inbuilt errors, so automatically you are inheriting or you are taking this error in your database. Second kind of error or source of error is computational error. So computational error is basically like a precision. So first thing is the how precisely you are doing the measurements. So precision basically is a measurement related accuracy parameters, like we can say how precisely we are doing the measurement. But when we are taking the measurements, suppose for example through our instrument like a GPS device or maybe GNSS receiver, so that time suppose my decimal places I have decided like 8 decimal places, right, when I am taking the measurement. But when I transfer this information to the computer system, I consider only 2 decimal places. Then that means I did this mistake of the computational error. So here the precision is another very, very important issue what you have to understand. So how precisely we are doing the measurement. So here sometime the precision also can be the engineering precision point of view or numerical precision point of view. That is a different point of discussion, but here the precisely how we are doing the measurement. So first point I told about the accuracy. Accuracy is basically out to the computations and precision for the measurement. So next source of error could be your human errors. So error in using the instruments, the selecting scale, location of sample and all. So sometimes the human resource or the person or engineers or technicians or the surveyor who is using this instrument is not capable, is not well trained, or is not having the sufficient skill to operate this instrument, also cause some error in the database. So that time when we operate a particular instrument, so we should definitely have to be very careful, either we are operating our instrument correctly or not. This is another source of error in the GIS. So data model representation, this is another error. So when you are doing this all computations, measurements, your data modeling activities, another source of error could be your data models. Either you have selected the correct data model for your data or not. For example, either you are storing your line features in the vector data model or raster data model. Similarly, some playground or maybe some buildings things, which data model I have accepted, because each data model has its own limitations and advantages. That time also you have to be very careful on this. Next type of source of this error is a errors in derived data. If your models or software or processing technique what you are using for your data processing purpose, whatever output it will give to you, if your logic, algorithms, processing techniques are not properly designed or developed, that time also you will have the another kind of error which is known as a derived error. So here you have to understand these three things what we are going to discuss is called error, accuracy and precision. So error is what? It encompasses both the imprecision of the data and its inaccurate accuracies. Accuracy is the degree of in which information on map or in a digital database matches true or accepted value. How near it is to the reality, that is called accuracy, and precision is called referred to the level of measurement and exactness of the description in the GIS database. So here already we discussed about accuracy and precision, but here you have to be very careful to decide the exact terminology in the GIS database which is fitting in your database. So basically either you are looking for or you are studying for error or is accuracy or precision. These are the three parameters what we study in this particular technology. Then another basic concept, as you know, that the data is a collection of fact from which conclusion may be drawn, and if you process this data it will become the information. If you model on this data and information, it will become the decision support system. If you include the knowledge base or knowledge on combined with this data, then it will become the your expert system. So this is a complete flow of information science, so where we study the data, information, model and knowledge. And here another important concept what you have to be very clear is quality. So data quality refer to the state of qualitative or quantitative piece of information, and then data is generally considered as high quality if it is a fit for its intended use in operation, decision making and planning. So here one important point what you have to understand what we are discussing in this course is like spatial resolution. This is one example I am taking here. Suppose you have a national level planning requirement, then you will go for like 1:250,000 scale maps or maybe satellite imagery of around 50 meter spatial resolution. But if you are looking for the city level planning, then you may require the high resolution satellite image or high scale maps like 1:10,000 or 1:4,000 scale map, or maybe 50 centimeters spatial resolution satellite imageries. So here all the data whatever we are using or capturing in this particular domain has their different uses. The purpose is totally different. If you are looking for the national level planning, then 50 centimeter spatial resolution data will not work there. In fact, that is not required. So it depends your scale and the level where or what is your intention. So if any data is fit for its intended use, then especially for the operation, decision making, planning, then if we say that its quality is good. So you cannot say that if 1:4,000 scale maps are available, then 1:50,000 scale map doesn't have any use. It definitely have the use, but its intention or its use is totally different. So that you have to understand very carefully in this particular domain. The data quality is a function of intangible properties such as completeness and consistency. So these are the two parameters generally we discuss here. So either my data is consistent or data is complete. What does it mean? I will give you the example of the road networks. Suppose you have the road network or road data of a city, And this road data, if I say I have the all the road data or road data sets of Dehradun city, so then next question will be either this is a correct data, what is the quality of this data. So then how you will decide either it is a correct and good quality data is there or not. These are the two parameters. Either data is complete, that means either all the roads are digitized, are available in this database, point number one. Second is data is consistent. It should not be one road is digitized halfway and half is left. For example, IRS campus in Dehradun is in the Kalidas road, but Kalidas road is mentioned in the database, but it is it's completely available or partially available. That is also a very, very important point. So here the completeness and consistency are another two parameters which basically are used to define the quality or to qualify a data for its use. Data are the result of production process, and the manner in which the process is performed clearly affect the data quality. So how we decide the data quality basically depend how we are creating or collecting this data. So based on our data model and methods what we discussed in last slides matters here. So data quality component in GIS, basically you have to see here how we basically measure it. Here if you call about data quality, we discuss about the locational accuracy, attribute accuracy, temporal accuracy, lineage, completeness, logical consistency. In the last slide I talk only about the last two parameters called completeness and consistency, but in the addition to that the next parameter is a lineage. Lineage is basically age of the data. So for example, suppose today you are capturing a or you are creating a land use land cover map. Okay, in 2020 you are creating a land use land cover map, but whatever map you are creating today, so if you are not putting the timestamp on this data, then maybe after 10 years your data will not have any use. I will give you the example here. Suppose I have one land use land cover map of India, and this map was created in year 2000, maybe, right? But I am trying to use this data in 2020, that means after 20 years. But some of the land use features may change. Maybe some piece of land was classified as agricultural land in 2000, but in 2020 this land is changed to the residential land. So now I cannot say the 2000 map is not correct. The 2000 map was correct at that time, but today, since I am using after 20 years, the age is changed, time is changed, then data quality is automatically changed. So what we required? We required the updation of this data rather than recreation of this data. So lineage is another parameter. Generally what people are doing, they are missing this point, and this information they are nowhere recording in the database. When we are creating geospatial data, if time stamping is not there, then this data is not considered as a quality data or standard data. Then next point is a temporal accuracy. Same thing, age of the data, then next is a temporal accuracy. Temporal accuracy basically we talk about how the land cover or how the geographical features are changing in due course of time. And that is a beauty of remote sensing technology here, the satellite based observation. The satellite is basically capturing the image on certain time interval. For example, suppose today one satellite image is captured for Dehradun. For same region, satellite will capture this another image maybe after 20 days, after 25 days, or sometime 5 days or 10 days also. Then I can compare how the features are changing, and that is the beauty of the satellite remote sensing. So all the satellite imageries are having the temporal resolution. My colleague must have discussed about the different resolution during the remote sensing class. So temporal accuracy, another very, very important parameters in the geospatial data. Then attribute accuracy. Attribute is basically data collections what we are collecting through ground survey or field based survey. So here how we are doing this survey, how we are collecting the data, what is our method, what instrument we have used, who was involved there, what was the skill set of the human resource. All these matters on the attribute accuracy, and how this data was transferred to the computer system. This is another parameter. Then location accuracy. Location accuracy is basically how accurately it is meeting or matching with the reality. Sometimes we call it the positional accuracy. And for to measure the location accuracy, we have some method called RMSE, like a root mean square error, or we have the this one epsilon band. These are the method I am not going to discuss in detail because it will be too much. But my objective in this class is only to give you the idea how we basically do this quality assessment of the data. Another very important point is a metadata. Metadata is what? It is a data about the data. What does it mean? So data about the data, for example, you have the satellite image. What is the characteristics or what is the data of this satellite image? Like which satellite sensor was used, when this data was captured. I am giving some example. What is the spatial resolution? What is the spectral resolution, like how many spectral bands are there? What is the radiometric resolution of this image? When this image was captured, right? And what was the geographical coverage of this data? All this information is called as a metadata. It qualify or it give the definition of your geospatial data. I have given the example of the satellite imagery. Now same metadata is applicable for vector data. So for this purpose we have certain metadata standard, especially in India. We follow the metadata standard published by National Spatial Data Infrastructure, that is a one body in the Department of Science and Technology, Government of India. They have published the metadata standards for vector as well as the raster data, and here around 28 parameters are given for each geographical data, either it's a raster or vector data. Out of 28, 9 are mandatory parameters. If you are involved in any operational project or research project, especially in the geospatial community, then metadata creation is necessary. Today, if you are not creating the metadata during your GIS project, that means after some time your data will not have any use, because this metadata will give the full data identifications, definition, quality parameters, distribution policies, pricing policies, ownership of the data, scale of the data, resolution of the data, and so on. So here please remember, whenever you are doing any GIS project or geospatial related task, so metadata you have to remember and you have to record very carefully. And these are the few factors, quickly I will go through, like age of the data, aerial coverages, map scale and resolutions, density of observations, data formats, exchange in the format, accessibility methods. These are the some parameters. All parameters are self-explanatory. I am not going to explain each and every one. These are the parameters which are basically affecting and the reliability of the geospatial data. So here, if you are simply drawing or digitizing some geographical feature, doesn't mean that you are creating the correct data. So you have to understand there is a very clear difference between simple drawing and GIS. So when you are working in the GIS, that means you have to take care of the different errors, quality parameters, metadata, and uncertainty in these data sets. So precision and accuracy already I explained in my earlier slides, but again I will read here. It says the precision is basically how exactly a location is specified, like exactness of the methods used. Accuracy is basically on how close it is to the true value. So precision is measurement related parameters, and accuracy is computation related parameters. That is a thing you have to very clear on this. One is a computation, second is called measurement. So here some examples are there given, like a decimal places point of view. This is just an example, but I am not saying that the precision means decimal, how many decimal place I am recording. This is just one example for the how precisely you are basically doing the measurements or capturing the information. Here the type and source of error in GIS. So here if you see the type of errors, there are two type of errors generally in GIS data will be there. It's called spatial error data and or attribute data. So when I say the spatial, that means I'm talking about the raster and vector data. If I'm talking about the attribute, then I'm going to talk about the non-spatial or these ground-based observations, basically what I'm going to link with my spatial geographical features. So source, instrument, human and changes, and errors are basically can occur during the 4 component of GIS, during the inputting of the data, data management time, data analysis time, and also during the presenting output of the data. So there is a chance, although you have the good quality data stored in your database system, but when you are presenting your data as a map, if you are not presenting or you are not following the standard cartographic principles like scale, like legend, coloring, shading, or direction properly, then automatically your map will have the errors. All the data is properly recorded, a good quality data exists there, but when I am presenting this data as a map output, if I am not following the cartography properly, then definitely I will have the inbuilt error or uncertainty in my maps. So first I will take GIS processing error. So here processing errors, basically, as I told you, the important point is how you are inputting the data into the system. So there are different data models exist, like a raster vector data models, but here two models are very or two modes are very important. It's called spectrum data and topological data. So what is the difference here? So SPECD generally we are not practicing these days in the GIS. It is basically simply drawing the lines, and we are not considering any cross section at all in the spectrum data model. But in the topological data, we also maintain the relationship. It is a mathematical relationship between the earth object. So here I think my colleague already discussed about the topology. So is the topological relationships are another very important point what you have to keep in mind. So topology is the special relations between the geographical features and which we have to take care in the database. These are the some examples of the GIS inputting, like when you are digitizing. So if there is a dangling or polygons, or there are slivers, these things create the problem. But these days our GIS softwares are capable to identify such errors in the data inputting system, and they will ask you to correct immediately, so that the proper topological relationships are built and data is stored properly. And these are the examples of topological errors in the vector data. So topological errors, as I told you, that are basically errors related to like continuity, association, contiguity, and these relationships. These are the mathematical relationship with the different geographical features what we have to take care in the GIS. And without topology or topological relationship, there is no use of geospatial data. Otherwise this data will be treated as a simple drawing data or drawing files. And this is about the GIS processing errors, like data precision too little, too much. So that is very important. So how we are measuring it, or how we are doing the measurements, either we have taken too much measurements, or sometimes very less measurements. I was giving example of the decimal places, same thing you can relate here also. Sometimes we are not considering the null value in the database. You have to understand 0 is not null. So there must be some provision to address the null values. For example, suppose you have the automatic weather station in your project, and you are receiving the data from the automatic weather stations, and but by some issues in the instruments, some issues in the sensors, some issues in the networks, if you are not getting the data of the rainfall, wind speed, wind direction, temperature, and so on, if you have not taken care of the null value, and by default it is stored as a 0, then your analysis result will be totally different. 0 means 0 degree temperature. Null means temperature was not recorded. So you have to be very careful when you are doing the measurements or storing the data. So you must have provision to handle null value in your database. Generally all the database systems, you take the MySQL, you take the PostgreSQL, you take the Oracle, MongoDB, the MariaDB, and all, they have the facility to allow the null value in the geospatial data. So here you have to be very careful which data can be stored as a null. Metadata already I discussed about it. Next important point is unit of measurements. Here we also talk about the projection system. We also talk about the datum. So in later stage, but when we are doing the measurement that time, so what is the unit of our measurement? That is very important. You have to decide very carefully which unit will fit my in my project. Data analysis point of view, like interpolation of point data into line, surface, or converting into contours. So this is very important point. So what is happening in GIS? Suppose I explained you about the interpolation technique. So what people do it, they understand the kriging is a one standard method available in most of the software, and they blindly apply the kriging in all the geographical features or all the terrains, and they say that I have the complete surface map. But here you have to understand, when you are applying the interpolation with the geospatial data, you have to consider the terrain also. The interpolation technique for your plain area will not be applicable in the hilly area. Their terrain is totally different. That time you may have to change your interpolation technique, or you may have to add or modify or edit some new techniques there. So here you cannot apply the blindly any interpolation technique in a complete your geographical area. That is an analysis point. This is one example I am giving you. Overlay of layers digitized separately from the different source or scale, example soil and vegetation. So here, suppose you are taking the input from different sources in your project. Suppose, for example, I will give you, you have taken the road network or infrastructure layer or base layer from the Survey of India, right? Land cover from ISRO, and then you have taken the forest map from the Forest Survey of India, and then you combine together and making your project. But if you are not considering the scale of this map, for example, if you are taking from the Survey of India is having the best scale, especially as a topo sheet, 1:50,000 scale maps are available. But if you are overlaying the 1:50,000 scale map on the land use of 1:10,000 scale, and then overlaying the 50,000 or 1 million soil map, 1:1 million scale soil map on this project, it is a completely gone case. Because the source of data you have to choose very carefully, and whenever you are making a project, you have to ensure that all the data is in a same scale or same resolutions. So you have to bring it. There are technique available. So here you cannot simply combine the 1:1 million scale data with 1:10,000 scale map. Very important. Although computer will do the overlay analysis, software doesn't know what is the source of your data. If you ask the software tool or quantum GIS or RGIS to do simple overlay analysis, it will do it. But the problem is, if you are not giving the correct input to the system, the output will have always a problem. Then sometimes you have the slivers, sometimes the border issues. Like if two geographical feature has to share the boundaries, but you are representing as a two separate boundaries, then it will have the different issues with your database. There are certain issues in the classification also. The compounding effect of processing and analysis of multiple layers. For example, if two layers each have the correctness of 90% and the accuracy of resulting overlay is around 81%. So that is also possible here in this kind of overlay analysis. You see this map, what is happening here? It's called I said that there is some doubts. If you represent this kind of maps, human eye cannot make a difference or between the two shade of same color. Sometime by seeing this map, you cannot draw the boundary exactly by which location a particular class is ending and another class is starting. This kind of devious analysis also people are doing, but in some cases it can give you some feeling, some overview, some conceptual idea about the geographical features or terrain. But this kind of representation of map is basically, when we are doing, it is also have some inbuilt error here. Default classification of the boundaries. This tool is available in all the GIS software. So suppose you have some values stored in the attribute and you say that classify in 10 classes, 20 classes. What is the logic of it? You have to be very careful on that. How many classes are required? And when the system is basically normalizing or making the group of the different values, you have to see either it is correctly doing or not. We should not completely depend on the software, whatever software is doing. Software is like a black box. Okay, so suppose you are not understanding the full process of the software, then you cannot produce a good quality output from this data set, although data is properly recorded in the server. Data units and bed classes, that is another examples what I am trying to show you here. So in fact you can refer these slides in in offline mode also. So you see here, so here if it is a gap in the data unit itself, sometime I am saying it is a centimeter, sometime I am saying it's a millimeter, sometime it is represented as a some other unit. So this kind of confusions also create some errors in the database. So errors in data processing and analysis are very important. So you have to be very careful, and whenever you are getting involved in any GIS project, so please read this particular topic carefully. Okay, these are the again few examples on the attribute errors. So this is a typical example you can see in this diagram here, map A and map B. These are the 2 points here. So if you combine here, if by mistake, if you this is an example of sliver, that means the boundaries are not shared properly. Sometime if some features are missed in the point map B, the resulting map also will miss that feature. That is a simple example given here. This is about the project management and human errors like measurement error, typo errors, drawing errors, incorrect implementation errors, planning, coordination, incorrect use of device errors, and so on. These are the related to geometry. So rounding errors, processing errors, geometric coordinations, transformation, map scanning, and geometric approximations, vector to raster conversions, like that. So how you can control and deal with the errors? Basically you have to estimate degree of an error is an interesting area of GIS. So here this is a very important topic of the computational science, how you deal with this. So basically you have to address it by different methods. One is the initial data, when you are control the quality of measurements, develop the standard of your data, prevent the human error by giving the proper training to the or skills to the person who is going to involve in the data creation or mapping activities. And the data model is another important basically step here. So which data model you are choosing for your project also matters, what kind of data quality will be there in your GIS data sets. So there are different methods to check for the errors. There are probably the simplest mean of checking of the data errors is by visual inspections. You can check either your maps or data are created properly or not. But of course, if your geographical area or mapping area is very large, so visual inspection may not be possible there. So then some computation techniques you can develop. You can use some tools, so that tool can identify the different type of error in your database, and once it is done, then you can fix it. These are the simple example of the output errors. So here 2 colors are representing basically 2 classes same color, 2 classes in the map with the same color. So human eyes can basically differentiate between the limited number of colors. So here when the more number of classes are basically captured during the data creation process, so that time you have to be very careful in the choosing of the color scheme. So here in the GIS softwares or environment, there are different methods are available. It is not only the color scheme. You can put some shade, some dots. If you are from geography background, you know that in cartography how we do this kind of classification or region creations, so that you have to be careful. So here it is not only your computation knowledge, it's not only your software knowledge, only not remote sensing knowledge. So here cartography knowledge is very important when you are creating the map using the GIS technology. So this is a summary here. The computer data have as many or more errors than printed map. The difference between the accuracy and precision, you know about it. Now the effect of scale and generalizations, lack of documentations, the need of metadata is very important, because metadata is a typical document of your geospatial data, which is necessarily required. And then age of the data in GIS is very important, that you have to record when the data is created, when data was captured. The effect of area basically is very important, like your boundaries, your legal issues also you have to take care here. So here these challenges are very important, and you have to take care when you are involved in any GIS project. So I will close my session here.